All right, so here we have another equation that looks very similar to the last one. However, if we look at our power chart, there's no row where 15 and 285 are on the same row. And actually, there's nowhere anywhere where 15 is even on our power chart besides just 15 to the 1. So here, what we want to do is actually use logs and the power rule to bring this exponent down, since we don't know how to solve for an x in the exponent. So what we're going to do first is we're going to take the log of both sides. And it's kind of just like multiplying by 2 to both sides, or adding 2 to both sides. It's algebra. So as long as we do it to one side, we can do it to the other side. So we just took the exact parts of each equation and just took the log of those. Now that helps us because we now have the power rule. Our power rule tells us that we can bring down this 3x out in front. So we now have 3x log 15 equals log of 285. And the reason that that's helpful is because now the variable we have is down in a normal part of the equation. It's no longer an exponent. So that's good. So now we need to get x by itself. In order to do that, we need to divide by 3, and we also need to divide by log of 15. And that way, 3 will cancel out the 3, the log of 15 will cancel out the log of 15, and we just get x. So if we divide the left by 3 and log 15, we need to divide the right by 3 and log 15. And then we need to make sure we're inputting this in our calculator right. Anytime we have logs, we have to automatically, our calculator makes us put it in parentheses. And then we also want to make sure that we put this whole bottom piece in parentheses as well as an entire quantity. So we're dividing the whole quantity. So the way we type this in would be log of 285 in parentheses divided by the whole quantity 3 log 15. And we would end that with 2 parentheses. And we get 0.6957, or 0.69 rounds up to 58. And that would be your answer. All right, over here we have something similar, but here we do not have an expression by itself. Since we have this plus sign here, we can't take the log of both sides. What we need to do first, before we do anything else, is subtract the 1 from both sides. So now we have isolated the expression that has the variable and the exponent. Now we can take the log of both sides. And again, the reason that we do that is because now we can bring this down. So this becomes y plus 2 times log 12 equals log 19. And now we need to get y by itself. So this is the quantity y plus 2 times this entire thing. So what we need to do is divide by log of 12. And so we would type that in our calculator, log of 19, close the parenthesis, divided by log of 12, and we get 1.1849. And that would give us over here just y plus 2. And then we can subtract 2 from both sides. And we get y equals negative 0.8151. And that would be our answer. So that one is pretty much the same thing, except for here, when we bring this down, we have to bring it as an entire quantity. And since we have PEMDAS here, we need to divide before we can add or subtract. So just keep that as an entire quantity, and then at the very end, your last step would be to subtract 2.